There's a lot of movement behind me today. All right, so I'm recording now. I am going to pull up my note paper and get a page ready for us. Let's see, let me put some lines on it. Okay, so I'm going to stop my video and I'm going to share my screen. We're going to get started. Okay. The first thing I want to do is I'm going to draw a picture like I did in 12.1, and we're going to talk about, you know, min and max and where these points fall and what they look like on a function. Okay, so let's say I've got a function, and the thing is, like I said, when you use a function to model, a lot of times functions go across the whole graph. But today we're going to be restricting the intervals. So I am going to restrict an interval on this function. I'm going to say I only want to go from this x value at a to this x value of b. So which means on my function, the only piece of my function that I'm looking at is from there, so from here to here. So when we talk about max and min, you know, obviously from the last couple of sections, I already know how to find this. Oh, it just looks, I don't know why I used white. It looks like I just erased it. I want to find, you know, I would find this point and this point, and then I could see which one was a max and which one is the min. But do you notice that this point for us right now really doesn't matter because it's not in the interval that I've restricted. So I also want you to notice the way that I closed my intervals. Notice I used brackets. So you guys, the way I would write the interval of this function would be this way. So I've got from a to b. So I might say, okay, we're on a function f of x, and the part that I want us to focus on is a closed interval. I can't help you right now, bud. Okay, you can just hold on until somebody else can. You know, I might say, okay, I want to focus on this closed interval from a to b. So I really want to get you used to the difference between a closed and an open interval. It's going to be very important to us today. And a closed interval has the brackets. That's how you know. It means that you want to go from a to b, and your endpoints at x equals a and x equals b are both going to be included in your interval. So let's look at our closed interval from a to b. Now, just looking at a picture, I should be able to find the minimum and the maximum value on this closed interval. And you might say, well, my max is over here, so I don't have a maximum value that's on my interval. But you guys, because my interval is closed, I actually do. So we're going to be using, again, min and max today. But if you're on a closed interval, we get to add another word to your min and max. We're going to have an absolute minimum and an absolute maximum. And let me show you why we get to use the word absolute. So as you're looking at this function, if I didn't have my interval there, you would have found this, this value as a max and this value as a min. But you wouldn't say that they were an absolute max or min. This value, while it is a max, it's relative to an area around it. It's a local maximum or a relative maximum. It's not the highest point on the graph or on the function, right? Because this arrow right here tells me that this goes up forever. So on this function as a whole, there is no absolute highest point, because if you think you get up to the highest point, you can go higher, right? And you guys, this value, we call it a local minimum or a relative minimum, because again, this function doesn't have an absolute lowest point. Because we've got this arrow going down over here, if you think you're at the lowest point on the function, you could still go lower because it goes on forever, right? But because I have closed an interval, I can say, okay, if I'm only looking at this little section from A to B, there is going to be an absolute highest point in this interval, and there will be an absolute lowest point in this interval. So I can use words like this when my interval is closed. Okay, so before we start finding these values on an actual function, let's look at some facts that are going to make it easier for us. So you get into a problem, and I say, hey, I've got a function. We're going from this point to this point only. That basically means we are not considering this part of the function, and we are not considering this part. I want to know what's the absolute minimum. So in just other words, what is the absolute lowest point on this interval? Well, you guys, there is only one, not one. There are only two places we have to check. And before we start checking, let's remember what it means to be a minimum. It means the lowest y value in that region, right? So I am looking for the lowest y value in this interval. Now, I can see where it's happening, right? It's occurring at that minimum that I could find in a lot of ways, right? It's occurring at a critical point because I can see in my picture that that is the lowest y value in the interval from A to B. Sometimes it doesn't though. You guys, sometimes it occurs at an end point. So you guys, when you're looking for an absolute min or max today and you're on a closed interval, we have to check two places. We have to check the endpoints and we have to check any critical points, but you guys, only critical points that are actually in your interval. I don't care about this point anymore because it's not in my interval. So, can you see from this picture why I don't really have to test this value and this value and this value and this value to see if they're the lowest or the highest in the interval? You guys, anything in between a critical point and an endpoint, it's not going to be your absolute min or max. Your only choices are critical points or endpoints. So I can see that my minimum is happening at this critical point just because I'm looking at a picture and I can see that this is where the lowest y value in the interval is. But let's talk about the max. So then you go and so you found that one, you're like, oh, found it, cool. Let's go to the absolute max. In this interval, my absolute maximum, first of all, is it happening at a critical point? Because I only have one of those in my interval and it was the minimum value. So it has to be happening at one of the endpoints. So we have two endpoints. We have this one where x equals a and we have this one where x equals b. So I think from a picture we can see that this point here where x equals b is the highest point on the interval. So it's not a critical point. It's just one of the ends. So you guys, the absolute minimum happened at a critical point that was a minimum, but the absolute max actually happened at just one of the endpoints because this is the highest y value that occurs on my interval from A to B. So again, can you see why you would not have to even try to check any value here or even here? You guys, if it's not an endpoint or it's not a critical point, there's no way that it could be a max or a min on my interval. These are all just going to be in the middle of critical points and endpoints. Let me give you another example in a picture before we do this algebraically. let's say I've got a graph and maybe it looks like this. Here's my interval from A to B. I can write a B. Let's say it's closed. It includes A and B, and this is my interval. And I want to know, hey, on this interval, what's the absolute max and absolute min? Well, I always do a first step here of finding any critical points for the function, because I know if there's critical points, they might be one of my answers. But you guys, if you find a critical point of this function, you're going to find it over here. And because it's not in your interval, you're just going to ignore it and say, okay, well, I don't have any critical points on my interval from A to B. So think about absolute maximum and absolute minimum. Where are they going to have to occur? Is there any way they could occur right here? I don't think so, you guys, because there's no way this could be the lowest or the highest point on my interval. You guys, it has to be at the ends. Because there's no critical point within here. So like, for example, if we had something like this, you guys, oh, there's a critical point that is lower. That might be the absolute min. Or what if you had something like this? Oh, there's a max critical point. But we don't have that, you guys. We're just going straight up from A to B. So it means that any point that's between those two, there's just no way, and you can just tell from the picture, there's no way any of these points in between could be my answer. And on this one, it's obvious that the absolute minimum, the lowest y value on the interval is happening at A, and the highest is happening at B. So let me give you a problem. And we're going to talk about how to solve it, what words it's going to have in it to know, and that's going to help me know what I'm looking for. Okay, so here's a function. You guys, I've got f of x equals x to the fourth minus 18x squared plus 1. And I want to find the absolute max and min. That's an and. That looks horrible. There we go. Max and min on a certain interval. So you guys, I want to go on the interval from -4 to +4. Okay, I have to fix that and sign. That's just really bothering me. Okay. Sorry. All right, so when I read through this problem, I see the max and min, and I say, oh, okay, so that tells me I probably need to find critical points, maybe test to see if they're max or min. But you guys, the word absolute implies that I'm on an interval. And you guys, these brackets imply that I am on a closed interval. So because I am on a closed interval, and you guys, you want to write this down because it's going to be hard to remember which method we use where. But when you are on a closed interval, what it means is that you are going to find any critical points in your interval. Remember, if you find a critical point, but it's not in the interval that you're dealing with, it means nothing. You guys, I'm not going to test it. I'm not going to look at it because it's not even in the interval. It can't be your answer. So you're going to find any critical points in your interval. And then you are going to test critical points in your interval and endpoints. Remember, your critical point, if it's in your interval, it'll be one of your answers. But your endpoints, there's a very good chance that either the max or the min will occur at one of your endpoints. So you're going to test any critical point that is in your interval, but you're also going to test your endpoints. And we're going to talk about how to test those when we get there. So you guys, we are in chapter 12. So our first step is going to be to take the first derivative. I've got to find the critical points. All right, so what's the derivative of this? Well, this is just straight power rule. You guys, this is just going to be 4x cubed minus 36x. And you guys, you might look at this and say, okay, well, I haven't had to set a cubic function equal to 0 and solve for x. You know, don't let that worry you. In this case, notice both of these terms have some common factors. You're just going to factor the easy way. You're just going to take out the greatest common factor from both these terms. So we are going to set it equal to 0. Remember, we're finding critical points. I think I can take a 4 and an x out of both of these. And what that leaves me with here would be an x squared minus 9. And you guys, now I have two factors. This times this equals 0. And I can set both equal to 0 and find my critical points. So when you have like a different type of function, we've been factoring a lot of squareds, right? And that reverse FOIL. Just remember, and especially in your homework from this stuff, there are a lot of different ways to factor. And sometimes they're easier like this. So you guys remember, you set each factor that actually has an x in it equal to 0. So here I've got 4x equals 0. And also x squared minus 9 equals 0. You can divide both sides by 4 here if you want. You're just going to get x equals 0. On this side, though, we have to be careful because I have an x squared. And I get x squared equals 9. So I have to square root both sides to solve for x. And guys, I do need plus or minus roots when I take roots today. So x equals plus or minus 3. That means I have 3 critical points. You guys, I have a critical point at x equals 0. And I have a critical point at 3 and negative 3. So go back up to your interval and think about the critical points that are going to fall in here. So remember, I have 0, 3, and negative 3. Do you guys, does 0 fall in the interval between negative 4 and positive 4? It does. What about 3? Well, it's in there too, you guys. It's between negative and positive 4, but negative 3 is also. So on this particular problem, we found 3 critical points, and all of them are in my interval, which means I do have to test all of them. So it means a little more work, but you know, they're all in your interval, so they all could be your absolute max or min. Now we just have to find out. So here's what we're going to do. So we did this step. We found any critical points that were in our interval. And now it says that I have to test those critical points in my interval and the endpoints. Here's the kicker on these problems. Let me go back up to a picture for a minute. Either of those pictures will do. Think about what I'm looking for. Remember, an absolute min is the absolute lowest y value in my interval, and the absolute max is the highest y value in my interval. So, do you think testing this point, for example, and finding its y value, do you think that even needs any derivatives or anything like that? It doesn't, guys. When I test this point, all I'm going to do is say, okay, at the point where x equals a, how do I find the y value there? Well, I just put it into the original function, right? And then if I want to test this point here where x equals b, how do I find the y value here? I put it into the function, just the original. If I had a point in here somewhere that I wanted to test, I would find their y values. What I want to do when I don't have a picture is kind of create a picture of these y values. So what I'm going to do is I'm I know all of these points, x equals 0, plus or minus 3. I know they're all on my graph, but I don't have a picture of that graph. And what I am looking for is the lowest y value in this group and the highest y value in this group. That doesn't require a derivative. So here's the kicker. When you are testing on a closed interval, this is what you really, really need to remember. You test the endpoints and the critical points in the original function. All you want to know is what the y values are there, and then you're going to compare those y values. The highest one you get is going to be your absolute max. The lowest one you get is going to be the absolute min. We just have to know where to test. And it always, your answer is always going to be an endpoint or a critical point. So the way I like to set these up is I like to put them on a list from lowest to highest. So remember, your endpoints are included. So your lowest endpoint will come first, and I'm going to test -4. And then what's the next value I come up to? Well, that's that critical point at -3. So I'm going to test that. What's the next value I come up to? Well, that's going to be the critical point at 0. Then I come up to a critical point at +3, and then I finish off with my high endpoint at 4. So do we see where I'm getting these values? 3 of them were right here. I have to test the critical points 3, 0, and -3. But I also have to test each endpoint given. So I have 5 values to test. And you guys, what I've done here is I've just put them in order so I don't miss any. This is also another way to make sure that each critical point that you're testing actually lies within your interval. Now, I have 5 possible min and max values. All I have to do is test them now. You guys, all I'm going to do is go to the original function and put each of these values in for x to get the y values there. So let's see. Here's our original function. I've got x to the 4th minus 18x squared plus 1. So let's remember that. So this is going to be -4 to the 4th minus 18 times -4 squared plus 1. And then I have to work this out. So let's see, what is 4 to the 4th? So you guys, that negative's going to go away because I'm taking it to the 4th, right? So 4 times 4 times 4 times 4. So 256 minus, you guys, this negative's going to go away also, but this one's going to stay. So this is going to be minus 18 times 16. So it'll be minus 288, and then I have that plus 1. So 256 minus 288 plus 1. You guys, what I get here is -31. So what I've just found is that when x equals -4, this is the y value on the function. Let's find the next one. So do the same thing, put it in the original. We're going to have -3 to the 4th minus 18 times -3 squared plus 1. So this gives me a positive 81 minus, hold on. It'll be minus 54 plus 1. So I get 28. And it is positive. So you guys, I get a positive 28 at this value. Testing the 0, that's always easy, right? Let's put 0 into our original function. It's 0 to the 4th minus 18 times 0 squared plus 1. So you guys, all that's going to be left there is the 1. So we get a positive 1 here. All right, let's test the positive 3. But before we do, you guys, I think just from what I know about the powers in this function, if I put a positive 3 in, I think I'm going to get the exact same value that I did when I put the -3 in. Why am I going to get that same value? Well, look, when we had the -3, we took it to the fourth, which canceled out the negative. And when I put it here and I squared it, Jack, you better watch that dog. If you don't want that chewed up, you better go get it. Sorry. So when I squared the -3, the negative went away. So basically, what I have written up here, the -3 to the fourth, -8, all that, is really the exact same thing I'm going to get on the +3 because the squareds took the negatives out anyway. So saving myself a little work. And if you work it all out anyway, that's fine. You're going to get the same answer. But we are going to get that 28 again there. What do you think is going to happen on the +4? I think it's going to be very similar. You guys, because these negatives disappeared, I'm going to get the same thing when I put in a +4. And again, you can still work them out if you're not really sure if that's what's going to happen. But either way, I've got 5 values. So let's imagine what this looks like. Now, I don't have a picture of this graph, but really, girl? Sorry. But what if I just kind of, and you don't have to do this part. This is just, I like to make an example on this one. So let's say 0 is here. Here's -3, here's -4. Here's +3, +4. So you guys, what I like to do, and this is not going to be to scale in any kind of way. I just kind of like to put these points where they might be on the graph. So at 0, for example, we're at 1. So let's put that there. At negative and +3, we're at 28. So let's just, pick a point and say, oh, well, that's 28. At negative and +4, we're down here at -31. You don't even have to connect these. You don't even have to know what it's looking like. I will connect them for you because this function is smooth. And again, it's not to scale, but this is what the function would look like on this interval, just, as a rough sketch. So what we found are these y values, right? And remember what absolute min and max is. It's just which one's highest and which one's lowest on this closed interval. So on my closed interval, what's the highest y value? Well, it's this one at 28. Where did it occur? What x value gave me a y value of 28? Well, it was actually 2 of them. Both 3 and -3 gave me this absolute max value. And you guys, if you have 2, that's okay. I would say there's an absolute max at 3 and -3. If it asks for the values there, the value there is 28. So the y value there is 28. And then let's talk about the absolute min. You guys, it's these down here, right? Those are the lowest values in the interval. They occur at 4 and -4. So absolute mins are occurring at 4 and -4. And if you need to, notate what the minimum y value is there, well, you already found it. It's -31. So you guys, this is us on a closed interval. You guys, biggest thing about closed intervals is this right here. You guys, you're going to still take the first derivative, but the only place we use the derivative is to find the critical points. Once you find them, all your testing gets done in the original function. So we find critical points. Now, remember, if you find a critical point and it happens to not be in your interval, we don't have to test it. There's no way it's a solution, right? But any critical points that are in your interval and endpoints, we put them in a list just like this, and we test in the original. Basically, we just want to know what their y values are so I can see which one's the biggest and which one's the smallest. So closed intervals are kind of honestly, they're more common sense type thing about how to solve it. They're like, hey, if I've got a closed interval, why don't I just find the biggest y value and the smallest y value? And that's absolutely what we're doing. The reason why we find the critical points is because on a closed interval, if I just said, hey, I need you to test a bunch of points, and I want to know what the biggest one and the smallest one is, if I didn't have this knowledge of which points could actually be my answer, how many points would I have to test? You guys, if I didn't have any guidance as to which ones are likely to be the answer, you know, there's an infinite number of values here. Am I just going to put all of them in the original and find all their y values? No, because I figured out that the only place a min or a max are going to occur are at critical points or endpoints. So it really, all I'm doing there is I'm narrowing down my list of values to test, which is a good thing. You guys, even though we had to test 5 values here, it's still a lot less than the infinite number of values that are in that closed interval. So let's do another one. Let me find one or pull one up for us. Honestly, guys, the closed interval, I like it. Like I said, it's really, it makes common sense. You know what you're looking for. Most of our actual applications are going to be on open intervals, which we'll talk about next time. But let me try to find an example on a closed interval. They're kind of hard to find. Like I said, it's just most real world stuff doesn't have a closed interval. It has an open one. And we don't know how to deal with that yet. But I'm going to look for one real quick. I was trying to look for one earlier and I never found one. So hopefully I will. If I just look one more time. I could always take one that's open and then just make it closed, even if it didn't make sense. All right, I had a chat. Hold on. Let me stop share for a second. Well, so sometimes, let's say you're working on a problem and you find 3 critical points like we did. Sometimes only one of those will fall within the interval. And so we would only have to deal with that, or maybe only 2. In our example, all 3 did. If none of your critical points fall in your closed interval, then all you have to do is test the endpoints. Basically, your answer is going to occur at a critical point or an endpoint. So if there are 0 critical points that actually fall in your interval, you would just have to test the endpoints. I think that on your questions, you'll always have at least one that actually falls within your interval. The one that we had just now where all of them did, that was honestly not the norm. Let me see. So yeah, like I said, a lot of these applications are not closed intervals, they're open. So I might just make one that's, I'm going to use one that technically is open, but I'm going to call it closed. Well, no, I still can't find one. All right. Oh, wait, I think I just had one. Ah, dang it, guys. When I turn the page too fast. Okay, I found one, but it's not, it's just numbers. I want an actual example that has word, you know, like a word problem. I might have to wait till open intervals to get a problem like that. Let's see. Hold on. Did I not? I feel like I probably should have. Yeah, I didn't square. Uh-oh. I squared the 4 though, right? In the first part? Yeah, guys, I just, okay. No, that's my fault. Okay, yeah. So, guys, look what happened. When we were testing, oh, you guys can't see it. Hold on. Let me share it with you again. All right, something happened. And they brought it to my attention. I didn't square this -3. Or I guess I didn't really work that one out, but I didn't square that either. I did it on the first part, guys. I squared the 4, then I multiplied it by 18, but I didn't square that 3. That wasn't just 18 times 3. That was 18 times 3 squared. So our answers might change, right? Let's see what happens. Guys, yeah, I don't know why I didn't square it, to be honest with you. I said the word squared, but I just didn't do it. So hold on, guys. So you guys, this is going to change our values at negative and positive 3. So negative 3 to the 4th is 81. Minus, you guys, this will be negative 18 times 9. And it's minus 162, and I get plus 1. So it's definitely going to change our answers. So that would be negative 81, negative 80. So guys, our negative 3 and positive 3 values are not our max. They're actually our min. So my poor picture is absolutely, sadly, well, actually, I guess I didn't have to erase the 4s. But our picture was wrong now. So without me having to draw a new picture. So, yeah, Parker, you do need to stop. Okay, so look what happened, guys. I forgot to square 3, and then my whole answer gets thrown off because look what happened. My values at 3 and negative 3 are now my absolute minimum values. They're now the lowest values. So let's fix that, you guys. Now our minimum values are the 3 and the negative 3. That's where they occur. The value there was negative 80. So what's my absolute max now? Well, I think it's just 1. It's the only positive value we have. So you guys, your absolute value occurs at x equals 1, or no, at x equals 0, sorry, be careful. And the value there is 1. So I'm glad you caught that. Yeah, because it changed our answer totally. So you guys, where x equals 0 is actually the highest point of that function. Yeah, sometimes, you know, like you're working through a problem and you just can't see your mistake until somebody points it out to you. I think that's my most, if I get frustrated at any math thing, it's that. Well, now that I made that mistake, I don't know if we'll have time to do another example. I didn't ever find one anyway, so. Yeah, we'll just hold on, guys. There's, like I said, there's not, you'll notice that when we do applications, the closed interval stuff, while I feel like it takes the longest to teach, it doesn't have as much application as an open interval does. And like I said, sadly, I don't have time to do another example with you. But you guys, I guess what I want to do then is close with this. You guys, you're going to know in your homework if it's a closed interval because it has brackets. And if it has brackets, it's going to say, sure. Oh, yeah, that makes sense. Yeah, sure, I can do that. You guys, if you have closed brackets and you see the word absolute, this is the sequence of steps that you are going to take. right here. You guys, you're going to find critical points. If they're in your interval, you're going to consider them. And if they're not, then you just ignore them. You're going to test those points and your endpoints. But remember, the testing is just in the original function, just finding all their y values. Once you get all the y values, what do? We compare them to each other. You guys, we found the lowest and we found the highest. The lowest was the max, or sorry, the lowest was the min and the highest was the max. Notice even after our answer change, your minimum still had 2 values, and that's okay. And you would write both of them. Our max just ended up having 1, but you really are just comparing which number is least and greatest, as long as you remember to test them in the original. Okay, so I will try, I'm going to find, like between this class and our, class on Wednesday, I'm going to find a good example that's actually an application that has a closed interval. Because like I said, just a lot of them have intervals that are open, so I can't use them, but I want to give you a real world application. I'll find one, and that's what we'll do at the beginning of class on Wednesday, and then we'll move on to the open interval. Which honestly is easier, guys. This is the long one. But yeah, I'll do that. And I can absolutely, I'm going to be recording my next class where I will not make that mistake, thanks to you guys. If you want to watch me work through the problem without making a horrible mistake, I can link that to D2L also. I might even do a different problem, and then you would just get more practice in it anyway. So, sorry. Okay, guys, look for this. Well, I probably won't put, sorry, I'm having fights with myself in my head. I'll let you know if I put some homework up on this. We will have homework on this week. I just don't know if I'm going to put it up yet. I guess I can. I mean, if you're not ready to work it, that's okay. You don't have to. But I'll get some homework up on it. You could at least start if you wanted to. Okay. So I will just see you guys on Wednesday. Look for 2 links. Look for 2 links, and you can watch both videos if you want. And we will just continue this next time.